Renting artificial intelligence APIs forces software teams to pay a metered tax on every single sentence generated. Welcome to the Freshers. Today we examine how open weight models shatter corporate cloud lock-in. Third-party providers frequently double token fees, throttle throughput, or deprecate active models without warning. Sensitive customer records cross public networks, triggering severe regulatory compliance failures. An open-weight AI model publishes its complete neural network parameters publicly so anyone can host it locally. That weight ownership eliminates recurring subscription fees while securing sensitive operational files permanently. So now we recognize the financial trap of rented corporate APIs. However, constructing an empty local clinic facility still leaves us without specialized medical knowledge on site. That is why Kimi K3 drops 2.8 trillion parameters directly into public hands. Renting corporate APIs leaves teams vulnerable to price hikes, which local weight ownership eliminates. To match proprietary intelligence, we need massive scale inside our own clinic. Parameters are internal numerical knobs adjusted during training for transforming input data into answers. For years, open models capped at 70 billion parameters. Proprietary corporate labs guarded multi-trillion parameter secrets tightly. Then Kimi K3 dropped 2.8 trillion parameters on Hugging Face. That represents an unprecedented leap forward for open source AI. This brings full blueprints for a 2,800-bed medical wing directly to your local facility. Your local team gains deep, multi-step reasoning capabilities previously restricted to private cloud vendors. How can an open model store 2.8 trillion parameters without needing an entire power plant for one query? The secret lies in avoiding total parameter calculation for every generated word. A sparse mixture of experts is a neural architecture splitting a model into specialized subnetworks for selective execution. Without dynamic routing, processing 2.8 trillion weights stalls standard server hardware. Kimi K3 divides its facility into 896 specialized doctor desks. When a specific problem arrives, triage routes the request to 16 relevant experts. Active parameters are specific numerical weights calculated for a single output word. K3 computes only 104 billion active parameters per word, under 4% of its network. We now have fast specialist triage across 896 rooms. Yet reading massive patient files still exhausts memory without linear context handling. That brings us to linear attention engines. Sparse doctor triage keeps processing fast, but massive patient histories still clog memory without linear attention. To analyze entire multi-file software codebases, our local clinic requires an efficient memory system. A context window is the maximum text volume an AI holds in working memory at once. Standard attention rereads every earlier word continually, triggering exponential memory growth on long files. Kimi Delta attention is a hybrid attention mechanism for updating running summary states in linear time. Instead of rereading page 1 repeatedly, K3 updates a running digital chart as new text arrives on site. This unlocks a 1 million token context window for analyzing 1,500 text pages. Software developers feed 50 full code files into one prompt without blowing GPU memory limits. Remember those 896 specialist doctors from our earlier triage desk? Early mixture of experts architectures suffered from router collapse, where 90% of traffic flooded 5 popular rooms. The remaining experts sat completely idle, becoming useless dead experts during training. Quantile balancing routing is a deterministic routing algorithm for distributing tokens evenly based on score quantiles. Think of a chief triage nurse directing incoming patients into equal waiting queues across all clinic rooms. This guarantees 100% expert utilization across all 896 subnetworks. So now our clinic runs running patient charts and balanced specialist rooms efficiently. However, storing those 2.8 trillion uncompressed weights still requires massive supercomputer RAM. Next, microfloat quantization shrinks our clinic files onto standard server racks. Even perfectly balanced experts take up terabytes of RAM, requiring microfloat quantization to fit on server racks. This hardware pivot answers how we host 2.8 trillion parameters on-site. Quantization is the process of reducing numerical precision in model weights for shrinking memory footprints. Uncompressed weights for Kimi K3 demand over 5.6 terabytes of GPU video memory. A GPU is a specialized parallel processor for accelerating neural computations. Quantization-aware training compresses parameters to 4-bit microfloats during fine-tuning to prevent reasoning loss. MXFP4 quantization shrinks K3's memory footprint by 60% while maintaining peak frontier intelligence on code benchmarks. This works like compressing paper diagnostic charts into high-density microfiche that retains every critical patient detail for precise diagnosis. Standard enterprise servers can now host a model that previously required a supercomputer. Earlier, we saw how rented corporate APIs drain budgets through continuous per-token charges. Now that hardware compression lets us run models locally, where is the financial tipping point? The hardware deployment threshold is the minimum infrastructure required for hosting a model locally. For Kimi K3, running full self-hosted inference requires roughly 64 enterprise GPUs across 8 server nodes. Weight ownership in self-hosting is running model software on private servers for total privacy and 0 per token fees. Processing 10 million daily queries via cloud APIs costs $50,000 every 24 hours. At that scale, purchasing dedicated local hardware pays for itself in under 60 days. So now we hold the exact financial crossover formula for on-premise hardware. Knowing the economic tipping point means nothing without an actionable deployment playbook. Next, we execute the production deployment strategy. Knowing the tipping point, where self-hosting wins, means nothing without a production-ready open deployment strategy. Here is how open models are permanently altering software engineering. Catch-up cycle shrinkage is the rapid narrowing of the time delay between proprietary releases and open-weight model equivalents. The performance gap shrank from 18 months down to under 3 weeks when Kimi K3 debuted. K3 secured the #1 rank on vllm Arena's front-end code arena benchmark, outperforming proprietary flagship models. Open-source serving engines like vllm delivered production-ready optimizations within 48 hours of release. Building on open weights yields 95% of frontier intelligence with complete data privacy and 0 token fees. If this breakdown helped you unlock open weight models, subscribe to The Freshers, hit the like button, and leave a comment with the next AI architecture you want us to dissect.